Welcome back to video number 3 about UEFN optimization, Fortnite optimization by GameDevMicah. Alright, we're going to go to we're on page 6. The second video covered page 1 through 5. First video talked about overall framework and how computers work in passing data. The overall method that I'm going to keep hammering home is less is best. Less detail, less data will get passed around faster by computers or devices that are trying to render it or show it, and result in better frame rates. And that's ultimately a better experience or smoother experience for our environments and players. Let's talk about the memory thermometer and what it is. So Epic has provided a tool for Fortnite called the current memory usage, sometimes referred to as the memory thermometer. It's this little device here you'll see in the middle of your screen during the edit mode that shows out of 100,000 how much resources you're using. In video 1 we talked about how computers have CPUs, GPUs, VRAM, RAM, hard drives, even some memory directly accessible on the CPU itself or a cache. The current memory usage is trying to provide us an idea of how much data we're shoving out to all that equipment. The smaller that number is, the less data being shoved out, the faster it computes, the more frame rates we get. And so that's what it's really generally trying to do, is get some math out there based on the components and the set objects that make up an actor or an object in the Fortnite world, and give it a number so that we can try and keep things working on our weak devices that don't have a ton of cool hardware toys like our PCs do. Using instant static meshes, which is a GPU way to render a bunch of the same mesh for cheap, we can really cut down a lot on what showed up in the memory thermometer. There is some worry that custom assets or actors aren't caught in the memory thermometer and might be caught in the future or added in the future and take up additional space. I don't know. I haven't had an official word on it. The answer is, for me, is that the H-Lot system uses ISMs, and so they're a critical part of what the environment is made up of every day. And also the official direction for for Unreal Engine is that ISMs or HISMs are the best thing to use for rendering. So since Fortnite's based on UE5 and ISMs, instant static meshes, and hierarchical instant static meshes are what the Fortnite hierarchical level of detail system uses to represent the environment in the most efficient way, I don't see how these things can ever not be the focus of what we're working on, except for Scene Graph. What Scene Graph's going to do is basically what I'm talking about in this entire document. Make your environment as light as possible with an actor with just a static mesh component on it, instead of all the extra classwork you would have on there with UEFN props that allows you to hit them and break them and build on them if you don't need that. And Scene Graph is going to make up entities with components on them which are lighter than an actor with a component on it. So we're doing what we can do prior to Scene Graph, but once it comes out, that basically implements all these things I'm talking about, but from Epic. So pay close attention to that memory thermometer. Do what you can to tune your items to reduce it down, and we'll have to see what happens over time about the ISMs and HISMs impact there. So I'll read through this one by one. So to get to the memory thermometer, you have to be in edit mode. You can do an unchecked auto start game from the launch session and start directly in edit mode if you like. Warning, current memory usage may become out of sync with changes done during a live edit. A yellow caution symbol will indicate a change has been considered. Press push changes and you may sync again. So this also ties up into the prior page, the project size and stuff. Sometimes these things will be out of sync with edits done that are not saved and then also pushed up to the cloud. So that's what I've seen is how you can update and get those things to be correct, is by pushing them up to the cloud. And so I kind of don't use live edit myself. I do everything in editor, then hit play and check it out on a device. So if you're in a UE Fortnite creative mindset where you hit play, go in edit mode, and build your levels, you might have some slow updates between the memory thermometer and the project size tools and stuff like that that you have to actually push and save. All right, so when the player camera moves around the world, it loads in assets. So when you have the world partition system enabled, you get the option to check off on actors is spatially loaded. Now, you don't have to include every actor in the HLOD system in order to use the spatial loading system, but the distance at where you'll load or unload actors is based on those tile sizes and your loading range. So when you unload an actor, it takes it out of the memory thermometer, where if you were to hide coal or an actor instead, it would stay loaded and should still impact that memory thermometer. So spatial loading of and actually loading or streaming out the actor is the best way to get rid of that data and help us be less is best. You could, with how I have my levels set up right now, with a streaming distance of 0, so that it's only the HLODs, everything immediately unspatially loads. So I have no actors in the world. All I'm ever looking at is the HLOD. That's extreme. And, well, that's what I do, right? I'm a performance guy. I'm going to show you the most extreme examples. It's up to you to say, well, we need these actors to spatially load in at this range because of whatever reason it is, or we don't, and the visuals look good. That's things you're going to have to see how it works with your levels. There are options that I did look at, which is for using multiple world partitions in your HLOD. In UE5, the full engine, you can go ahead and make multiple partitions, have actors pick which partition they're in, and they get different streaming ranges. They can also have different HLODs built. That is exposed in Fortnite, but it will not package. So we cannot use multiple partitions, even though you can configure them and maybe hack it in there. It just won't package all the way through. And that sucks, because we could get things like I'm kind of showing on page here, which would be spatial loading distances. So you could have small props that would actually spatially load out. I'm sorry, I'm just building up your hopes. Right now, multiple world partitions are not supported in UEFN. Only a single HLOD partition is, which means you only get a single spatial loading range that you can use, which will match where that HLOD turns in and on and off. If you can script via verse or anything else, your own stuff, to unload or destroy actors when they're not needed, that lightens up the overall system, and less is best. All right. The spatial profiler, that's a top-down view of your memory thermometer over the level. This is to try and help you basically see with colors a visualization of how heavy your level is that gets crunched by UEFN. So it's useful for you to sort of try and see overall in your level where you might want to convert to ISMs or remove some devices or something like that, so that you'll get a higher frame rate in that area on every device. So it's trying to show you your problem areas. Statistical audits. This is a tool that provides detailed views of the assets used in your project and be configured to see multiple different sorting views. You should use this to quickly review your project to see which assets or actors are costing you the most in rendering, memory, and impacts. It can be sorted by instance count totals, so how many of each mesh is used in the world, actor sizes, and many other sorting methods, like materials and primitives. I think I show them here. Statistical audits sorted by primitives with current level, try poly counts with items in your level. So this is nice because I'm showing here that doing a spatial audit by primitive stats, you can see what your mesh is in the world, or how many of them are used, how many instances in your level there are, and then also how dense the impact on your sizes on your disk. So this is where you start to go look in your project and find out, what's the heaviest thing. That's typically how we do with optimization, is we go try to find your biggest bottleneck and reduce it. And then once you fix that one, there'll be a next one that's bigger than it, and you just keep working on the ones that are the biggest, typically. Then once you do that to a point where you're like, I can't really make any changes to these big ones, I've done enough that they look like the weakest, the smallest detail I could do. Let's go ahead and start looking at smaller objects that are used more frequently, that maybe don't have as big of an impact, but we're using them a lot. So just keep digging down until you've addressed everything at some level, and you're like, no, I've tried to make it smaller. It feels as good as I artistically want it to, and if I make it cheaper, less vertex, less texture, it won't look like the art I want, and so I can't. That's where you manage your performance and optimization to your art direction minimum. And you want to do that rather than having a bunch of extra stuff that isn't really helping with art direction. And art direction is the style of your environment, the style of your level, the feel you want. If you can get the feel, you want to get the feel you want in your level with the least amount of data or the least bulky assets. You can sort by actors. This would be sort of like that accumulation of an actor, of the components of it, to help you again with like, hey, maybe this one actor could be lightened up. Maybe you have a sound file on an actor and you're not playing the sound. This should hopefully show you, hey, this actor still has these accumulation of data associated with it. Texture statistics. This is like meshes, but only for textures to help you show how big textures are, and maybe you can say, hey, I didn't know, the texture on the bottom of that item that I never see is a 2K texture, which is the biggest texture you can have in Fortnite. It could be a 1 by 1 if it really mattered, just a color. So this is where you can catch those type of things that you're just not aware of. And that's what a lot of these windows, I think, do, is help to show you or point out the heaviest things that you in your environment and help you be aware of it. General asset optimization. Most assets are made of multiple different types of data, or actors. A static mesh includes 3D vertex data and a reference to a material. That material can reference multiple textures itself at different resolutions and detail. This growing data must be loaded into memory and used within the video game. In general, less data is more efficient, but at the cost of detail. When detail is equal between the two options, always choose the lighter. Less data, less execution, functions, or framework. Texture and mesh data makes up the majority of the data in your project. So you're mainly, easy things to do is to go through and make sure your meshes and materials are as light and textures are as small as possible, least resolution to meet your art direction need. Texture resolution reduction greatly impacts texture and reduces memory impacts. And RAM, driving better frame rates and smaller memory requirements at the cost of detail. So if you have a 4K texture and you reduce it down to 2K, you could fit 3 other 2K textures in that same memory space as that one 4K. You get 4 total 2K textures inside the space or of storage space of one 4K texture. And that just keeps happening the smaller down you make textures. There's some textures that you'll see the difference. So like a albedo and a normal map that are the two primary maps for a material. Those at 1K or 2K makes a good idea. Roughness and metallic or AO or things like that aren't as noticeable as the normal is and the albedo textures are. So you could maybe reduce those down much smaller than the albedo and normal are and pack them in and into the same memory space. So maybe you have 256 or 512 AO, metallic, or roughness material textures, and you have a 1K or 2K albedo and normal, rather than having all of them be 2K. And you'll fit them in the space of maybe 3 textures instead of the space of 6 textures or what have you. And that's the whole idea of the memory footprint you need, reducing that down to what your art direction requires. About 5 more minutes here, we'll hit another page. Virtual textures. Virtual textures require all textures to be a power of 2. So when you'll import a texture, if it's not a power of 2, you're going to get a little error like you see here saying that, hey, the texture can't support streaming if it's not a power of 2. Convert them to a power of 2, I'm pretty sure that means that all textures are by default enabled with streaming in Fortnite, as long as you convert to a power of 2. Now, what is streaming virtual textures? That is where you have a single pool of memory for textures. that you stream in textures that you need at the resolutions you need and shove them into that pool and remove them from that pool as well. So you get kind of a locked amount of texture data in a pool that you can send textures in and out of. If you don't stream data, then if those textures are needed, they will be loaded on the RAM in full and stay there for as long until you unload them some way. Streaming is that loading and unloading way. So if it's in your level, if the asset's loaded, it will be into your memory if it's not a virtual texture. But if it's a virtual texture, it will only be loaded in your memory if you're looking at it and you need to render it. So it's kind of like get everything you can in a virtual texture, which is why I think it's on by default for everything, unless you don't convert it to a Power 2. To convert to a Power 2, it's just there's a right-click button and it does it. It seems to work pretty well. Also, to reduce, there's a reduction tool to reduce textures. When you reduce a mesh using the tools, I believe it still saves the entire detail of the mesh on the disk and shows you the reduction one, where reducing the texture using this tool seems to save only the reduced texture. What this is that your package size, the actual asset on disk, Unreal may want to save the heavier one and keep the space. So using on textures, it won't. It will get rid of the heavier one and make it smaller from what I've seen. With meshes, it will save the heavier one. So you might have to actually export the reduced mesh and then re-import it as a custom reduced mesh to have the size on disk savings there. So make sure you keep an eye on that and see that when you reduce down polys or reduce down the size of the texture, you do see the actual disk size get reduced as well. So in here, I'm showing that action. So my texture I imported was a 5000 by 2000 texture. By converting to a Power 2, it made it into a 4096 by 2048 texture for me. And so now it will stream. That size of the texture is 10 megs on disk. If we came down here and reduced it from 4K by 2K to a 1K by 512, that took the size on disk from 10 megabytes to 626 kilobytes. So we could fit, 20 times as many textures into that same space since we reduced it from 5K to 1K. So you can hopefully see there a very visual example of the impact on our storage and making less out of that texture. Removing material slots. So Epic recommends no more than 3 texture slots on a skeletal mesh. So just to give you an idea, there is a recommendation out there around this. So removing material slots on a custom asset that are not used will help reduce draw calls, because every mesh is a draw call, and then for each material that is on that mesh is an additional draw call. So the less materials will be the more efficient you can render the asset. So let's just read about that. Each material slot is on a static mesh will cause the GPU to render an additional draw call. Draw calls are the work that a GPU/video card does. The lower the total count of draw calls, the faster the GPU can produce frames, the higher frames per second. Less is best. To remove a material slot from a custom mesh you imported into Unreal or have made with the editor, aka non-UEFN assets, place the mesh you need to modify in your level, then use UEFN's modeling mode, attributes, edit materials option. From there, you can go ahead and right-click on the materials or use the drop-down right here and hit delete to remove materials that are not assigned. It will, depending on the order, assign that material as the remaining UV space. So, if this is modifying the mesh. Hopefully you don't have a whole bunch of materials on your meshes. If you do, there's programs that can help you bake it out, and UEFN's modeling tools have options to help you try and bake out the textures too. Going into model modifications is going to make this video really long. So just want to let you know there are spots to easily remove maybe unused textures or reduce down what's on the model directly in Engine. And you will have to save the work after you do it. Materials, less is best, less textures, less nodes. So yeah, we're going to talk about materials now. Less nodes, less complexity. If you can, convert transparent materials or transparency materials to masks. So if you have letters or verbiage or words or icons, decals, anything that doesn't really need transparent fading, then a mask material is much, much cheaper than a transparent material for when you're just trying to get some transparencies. Here's an example on the right, translucency being 480 instructions, which instructions are what the GPU does to render that material. And when you use a mask material by default, it's 120 instructions. So you can see it's about 4 times cheaper if you can make your material masked versus translucent on the environment. So I recommend converting any transparent materials to mask as possible if the texture does not require you to blend it over its backgrounds. Use that transparent part. Try to use the mask mode. Always set the cheapest options when you don't need more expensive ones. And this is not how Unreal or Fortnite has configured all their things. All their things are configured in kind of a, I don't know what they were thinking about some of this stuff. I think there's a lot of carryover. Things like gravity are not enableable. Things like CCD, continuous collision detection, are not applicable. So things are just kind of weird. So you want to have things off that you don't need. So shading models, if you can go unlit, meaning no shadows, this would be things like icons or things that you don't need shadows on the material, do it. It will be cheaper to not have to have the shadows passed onto the material. And it will render faster and full color. Disable shadows if you do not need shadows or lighting on that material. On any UI or animated stuff is about materials, but it works for everything else, disabling shadows. Disable lighting on UI elements. This would be shadows or mesh distance fields. Anything on an element that doesn't need to impact shadows, get rid of it. Disable receive decals on UI elements in the world. So if you don't want a decal or don't need a decal to land on that mesh, don't let the material see decals. It's cheaper that way. It doesn't have to check for decals. It opts out of it. Texture reduction from 2K to 1K to 5K is recommended for whenever possible. 2+K textures are exponentially more expensive and won't render in Fortnite. They only allow a max of 2K textures. Shader so reduce your shader complexity, reduce your reflections. Specifically, look at reflections and roughness. If you can set reflections and roughness to 0, you won't have to do tracing for it and it will run much quicker. Look at the reflectivity shader mode in your viewport to help you see what is shiny. Every static mesh, every material for Fortnite has too much roughness and does reflections. You could null that part out. Reflections and shadows are the 2 expensive parts in lighting. All right, I think we're at 20 minutes on page 10, so we'll go ahead and move to page 11 in the next video. Thanks for hanging out. See you soon.